Okay, so tan hyperbolic square, it's actually e to the x minus e to the minus x over e to the x plus e to the minus x. Now this is square because that's a square. So I can skip the step and I can just square the top one and the bottom one separately rather than doing one and then do the other one. Now plus the sine hyperbolic. So sine hyperbolic, this is the formula for sine hyperbolic. It's e to the x minus e to the minus x over 2. And this is square. So rather me doing that one, I'm just going to square that one. And I'm just going to square this one. Now, let's have a look how we actually sort this one out. Before you open this thing up, the easy way to do that one is, if you have a look here, and you have a look here, these are the squares and the squares. But the denominators are different. The denominator of that one is 4. Let me write this one down. E to the x minus e to the minus x squared. At the bottom is denominator is e to the x plus e to the minus x. And on this side, the denominator is a 4. I'm just going to put the 4 here. Doesn't matter, you can put in the middle. Okay. Now I need to make the denominator same. The way to make the denominator same is we play X factor or cross multiplication. So what I can do is this thing, whatever this thing is, I'm going to write here. This thing, I'm going to also write here. So this 4, I can write here and I can write here. So I'm multiplying and dividing this thing by 4. And then on this side, this bit will appear here. There's a square as well. And it will also appear here as well. What I did is I moved this thing on this side and this thing on this side. So now if you have a look at the denominator is same. Why I did that one? Because of this reason. If I got like 3 over 7 plus 4 over 8 and I want to add them, I cannot add them because this is 7, this is 8. So to do that one, I multiply this side by 8 over 8 and I multiply that side by 7 over 7. So I got that's 56 and 8 times 3 plus 56, 4 times 7. So now I can add them easily.
Do you mean 8 by 8 or do you mean 4 by 8?
No, 8 by 8 because I look at the denominator. I copy this denominator, put on the top or at the bottom. See, this was 4. So I put 4 and 4. I multiply and divide with the denominator. Yep. So this is what I do. Or there's another method as well. It's called cross multiplication. Okay. Now, once I got this bit, because the denominator is same, so you draw one line. This plus sign will come in the middle. At the bottom, rather writing twice, let's say this is 8 times 3 is 24 over 56 plus 28 over 56. When you write this thing, you write 56 and you write 24 plus 28. Yeah. So I'm going to do exactly the same. So because the denominators are same, I will write the denominator just once. And then I write the top bit. That one is 4 e to the x minus e to the minus x squared. And that one is e to the x minus e to the minus x squared. And that is e to the x plus e to the minus x squared. Now I need to solve that bit. So now I need to open up the bracket. It's going to be long one. So now we need to just open up the brackets. Now to open up the brackets, the bottom one, I'm just going to keep same. I'm not going to do anything with the bottom one, but top one. This 4 is a 4. This one, because it's e to the x minus e to the minus x squared. For those who are not in the first session, this is that formula. It's a squared minus the b squared. So you square whatever the first thing is, a squared, plus whatever the second thing is squared. If there is a minus, you put minus here. Minus 2 times ab. So in this case, this first thing is the a and the second thing is the b. So what you do is you square the first one. E to the 2x plus e to the minus 2x minus 2. Now what happened to the AB?
Cancels out the next.
Yeah. So e to the x and e to the minus x, that becomes 1. So you don't need to write this one. Plus, now I need to do that bit. This one will be exactly same as this one. So that becomes e to the x, sorry, 2x, plus e to the minus 2x minus 2. And this one, when I open it up, it becomes a e to the 2x plus e to the minus 2x plus 2. They are multiplying. The blue one at the denominator, I cannot do anything about that, so I'm just going to write this one. Okay. Now the bottom one as it is. Now let's have a look at the top one. So rather than me writing the blue bottom one again and again, let's deal with the top one and just put it back. So let's deal with the top one. The top one will be 4. If I multiply that inside, which I can, 4 e to the 2x plus 4 e to the minus 2x minus 4 times 2 is 8. I can do that one. So I just multiply that green bit, 4 with everything. Yep, I did that one. Now I need to do the red ones. It's 3 times, so it's 3 and 3. That answer is going to be 9 different terms. So I need to multiply this times that, this times that, this times that, and then this times that, this times that, this times that. So it's going to be a long one. Let's have a look. First, what you do is you multiply this bit to this bit. So that becomes because there's a positive sign. So plus, let me use a red color, plus e to the 2x times 2x is going to be 4x. Yep. Then that times this one. So this is e to the 2x multiplied by e to the minus 2x. So that becomes a positive one. And then this times this is plus 2e to the 2x. Because that times that is 2. Now I need to do now next one. This time that is plus a 1 because e to the minus 2x times e to the 2x, because they're exactly the same except the power, they're negative, that will be 1. Now this times this, that will be plus e to the minus 4x and then plus 2e to the minus 2x. Now I need to do the minus 2 now. I don't have space, so I'm writing that one here. Minus 2 times this is going to be minus 2. I'm just going to write that one here. Minus 2 e to the 2x minus 2e to the minus 2x and minus 4. And the denominator, which is that blue thing, remains the same. So I would put the denominator in the end. Then let's solve the thing. Let's solve that bit. Let's have a look. Let's find the things that are same. If I have a look, this is 4e to the 2x. So I'm finding e to the 2x. This is e to the 2x. This is e to the 2x. And this is e to the 2x, isn't it? So they are all e to the 2x. So that's 4e to the 2x plus 2e to the 2x minus 2e to the 2x.
4e to the 2x.
So yeah, the answer is 4e to the 2x. Because 4 plus 2 is 6, 6 minus 2 is. Now I need to find the other one. Let's use a different color. Let's have a look at this one. Minus 2x. This is 1 minus 2x.
2.
And
1 on the end, 1 underneath.
there is a 1 here as well.
Yeah.
And there is 1 there as well. Yeah. So they two cancel. So the answer is still 4. Yeah, 4 plus 2 is 6. Minus 2 is another 4. So plus 4e to the 2x. That's done. Okay, let's have a look at the e to the 4. Or let's have a look at minus 8. So this is minus 8.
Is it not minus 2x?
Where?
Second one you just did.
That one?
Yeah, it's minus 2x.
Minus 2x. Okay. Plus 4.
4e to the minus 2x.
Oh, you mean minus 2x? Like
Yeah.
here. Oh,
Yeah.
it is minus. Come on. Okay. So this is minus 8. Yeah. Thank you. This is minus 8. This is plus 1. And this is minus 4. So it's minus 12 plus 1.
Minus 11.
So you got minus 11.
There's 2 plus 1s.
Or there's 2 plus 1. There's that one and that one. So
10.
It's minus 10.
yeah, so you got these ones. So that's minus 10. Now you're only left with e to the 4x and e to the minus 4x. So there's nothing like that. So I'm just going to write it down. Plus e to the 4x plus e to the minus 4x. Okay. No.
You can cancel them.
So is the answer minus 10?
No, you can't cancel them because this is e to the 2x 4. This is like 4 bananas. That's one apple.
They become one.
How come they become 1?
2 e's on the end.
That one?
Yeah. If you
Only if they multiply.
Oh, right. Yeah. Fair enough.
Yeah. Okay. So that you are supposed to prove this thing equals to 4e to the 2x plus 4e to the minus 2x plus e to the 4x plus e to the minus 4x minus 10. Yeah. So here you go. You can't solve any further. You can do one more step, but yeah, let's stop here.